an application for communicating with a test instrument, it'll be a fairly simple task, just asking for the machine's identity, but it'll give a flavour of how easy it is to get up and running. So from the LabVIEW homepage, we can create a new project and call this identity, if I can spell, test. And this is going to open up the project with one VI already created onto the panel screen. But the best way to get started is to just check out the system designer. So if we open up that window, you can see that it just shows an image of our computer with the identified instruments currently attached to it. At the moment, on the USB port, I just have one machine, my multimeter. And when I select that, you can see just some information about it down here. Now, normally you could talk to it via its visa resource identifier, which is pretty complicated. So I typically use a visa alias, and it will remember this across connections of the instrument to LabVIEW. So as long as it's unique, it could be whatever you like. But that makes sense, right? So going back to the function itself, on the panel, what we want to do to ask for identity is to be able to give the application the name of the instrument we want to talk to, and then it will run some commands, and we want to be able to see the identity displayed back. So our UI is going to be very simple. We can use the elements on the left hand side. Named references is just a component really that will detect which instruments are connected, so we've got a visa resource. I'm going to drop that on with the visa resource name, and if I look in here, you can see already it's found my multimeter. If I turn on other machines, they will appear in this list automatically. I can refresh the list there. So we've got my multimeter, and we also want to show the identity as it's returned back from the instrument. So for that, we're going to need a string indicator. Indicators are used for output. It's generally a fairly long name. So we'll try and store it in that field there. Okay, now you can see as we highlight elements, they are displayed on the right hand side. So that's what our UI is going to look like. It's very simple, and that's what you choose obviously will depend on the application you have. Now, very typically with LabVIEW applications, they also use error components to help control the flow of the application, so that once an error has occurred, it can flow through the application and be displayed at the end. So if we go and find some of those, so we can have an error in. Now obviously, because this is a starting VI, we won't be starting off with an error, but this is just so that the error can flow into application components and back through the VI components and back out of those components and follow a trail through. But you'll see as I build up the application. Okay, so on our diagram then, let's go into our tray, and these are all the items that we've put onto our UI that we'll need to communicate. So I'll drop those down there, and one of the very typical patterns we have is in LabVIEW is to start off with a case structure that is configured to work for in a no error situation, so when no error comes into the application, or if an error is passed in. Okay, now the normal state of affairs for when an error is passed in is that these are just communicated straight across and nothing else happens. There we go. And so if we pass an error in, nothing happens, the error is just passed straight out again. What we would like obviously to do is try and see what happens when no error occurs. So if we've got given a resource name, we can pass that in. Okay, and ultimately we'll want the identity out. Now, so for communicating with an instrument, we will be using Scuppy commands, and these can all be found within the, or the means for sending those commands can all be found within the hardware interfaces list here. So we've got some Visa elements. So the basic flow will be to open a connection, will be to write a command, will be to read a response, and then to close that connection. Now, in a typical application where you're sending commands, more than one command, this is very simple. You're sending more than one command. You only need to open and close the session once, if you like, for the duration of the application. But it's quite important to actually run through that close so that the connection is properly shut down. Otherwise, it might leave the instruments or certainly the application in an unknown state. Okay, so this is just a question now of linking these up in the way that we want to. So we've got our session, which we selected on the first page. That can go in to open, and you can see as you highlight the elements here, that these coloured dots are inputs and outputs. Typically inputs on the left, outputs on the right. So here we can pass in a session, we can pass in an error, which we would want to link in from here. And let's just rearrange that slightly. We can ask whether we can indicate whether we want to duplicate a session or not, or a specific type of access mode. Now, if this doesn't really make much sense to you, because it may not be, we can use, if we select the item here, we can use what's called context help, and you can see that this just pops up this indicator here. And as we hover over elements, it will show the information that we're interested in there. So access mode, for example, there we go. The context help is quite useful for things that you're not quite sure about, actually, rather than having to go and open up the whole manual itself. Okay, on the top we can also set a timeout. The timeout is currently 0 milliseconds, so let's change that to 5 seconds. We can create a constant to go in there, 5,000 milliseconds. So once we've opened it up, the session can come out and go into the right. And here you'll see that we're connecting the errors up. So the error flows in and error flows out, and typically it's following the same pattern as I'm showing here. If you pass an error into an element, then nothing will happen, but it will just be passed straight back out again. So when we're sending writing something to the instrument, what we will need to do is actually say what the command is. So for a identity on a Scuppy command, what we will want is an IDN command. And I've found that most of these instruments require the use of a new line character at the end. Now, when we're setting these up, we will need to just make sure that that's represented as a escape sequence, and you can see we can either see the escape sequence, or we can actually see the escape sequence or see the effect of the escape sequence. So here we're sending an IDN command with a new line character. Wire these elements up again, and so for a read, we want to be able to say how many bytes do we expect. Now, you don't want an exact number. You don't really want less than you're going to receive, otherwise that's all it will receive out of the buffer. So it's overkill for something like this, about 1024 bytes. It doesn't matter as long as it's not too small. And we can, once we have that, I'll just move that over a bit. Once we have that, then the element coming out is the contents of our read buffer, and we want that to go into identity. And finally, the error coming out. Didn't really want to do that. Want to wire it up to our error out. Let's just tidy that up a bit. So that is all we really need to send a command and read a response back, as long as it works, of course. So if we just go back to our panel, make sure we've got our machine selected, instrument selected, and run, we get an identity back. It's really not very much more complicated than that. You see we've got our list here, but let me turn on my power supply. If we look at the system designer, once the power supply powers up, we would hope to see that it appears here, and you can see here again, just like my multimeter, I've given it a better ID, better name, and in here it appears automatically, so I can select the name and run it again, and we get a different responses, which is what you would expect. So that is it, really. It doesn't get much more complicated than that. Now obviously this is a very simple application, it just does one thing. Typically you'd have multiple commands, you'd be running them in loops, you'd be probably communicating between multiple instruments at the same time. So the actual application will get more complicated, but fundamentally to send commands to a machine you're using a visa write and a visa read, so where a response is expected. So I hope this has been useful to see actually how you do that and how quickly it can be to actually set something up.